Welcome to Chapter 4, Introduction to Classes, Objects, Methods, and Strings. So, this is really going to get you going in C#. It's really going to give you the nuts and bolts of what you're going to need to get moving and developing. In Chapter 3, we talked a lot about the initial issues that you run into with understanding what you're looking at when you're programming. However, with classes, objects, methods, and strings, essentially what we're looking at is what makes up C# and how we can manipulate it for our benefit. So let's get started. Get my pen out and let's go. Classes, objects, methods, properties, and instance variables. So that's what we're going to talk about. And here's an example. A car begins as engineering drawings, similar to the blueprints used to design a house. An accelerator pedal hides the complex mechanisms that actually make the car go faster. Before you can drive a car, it must be built from the engineering drawings that describe it. So in this case, they're giving you a little bit of an example of how a car is built. No one just walks into a factory and starts putting a bumper onto a steel rebar. No one walks in and says, okay, the handle goes on now. There's an actual blueprint to how it all works. Now, give me a second. It looks like I can't draw, and that's an issue because I want to be able to draw. Give me 2 seconds to fix that. Resume slideshow. Why can I not draw? Normally, it won't let me do it if I'm highlighter. Nope. That's unfortunate. Well, I'm just gonna have to make without it then. Or give me 2 parsecs. One more time. I'm gonna close the slideshow and open it back up. Discard, close, and then we will try that again. All the best. Here it comes. There we go. No, I'm not going to do that. Let's do that. Let's swap. There we go. All right. So, a method describes the internal mechanisms that actually perform its tasks. A class is used to house, among other things, a method. It also houses variables, functions that are called from classes, other classes. It can house a lot of things, actually. Just as a car's engineering drawing house, among other things, the design of an accelerator pedal. A class that represents a bank account might contain one method to deposit money in an account, another to withdraw money from an account, and a third to inquire what the current account balance is. Just as you cannot drive an engineering drawing of a car, you cannot drive a class. So what the class really is just a blueprint. And you'll see that as we go forward. If you look at Chapter 3, we kind of go into great detail, or we kind of skim over, I guess not go into great detail, the idea of a class and what it actually does. A class is really just a compilation of objects. Normally those objects are like objects. And if we follow the right principles, then we'll understand what to put in a class. So, according to the solid principles, a class should have a single responsibility. And what does that mean? Well, what that means is that a class should only do one thing. Now, it might do that thing in 4 or 5 different ways, but it should only be responsible for doing one thing. I like to use the print function of a computer or a printer as something to explain that. So, for instance, you can print to PDF, you can print to CSV, you can print to many different things. However, printing in and of itself should be the sole responsibility of that specific class. Now, it doesn't mean there's not going to be a bunch of other things in that class. I know, flip over real fast. That will do other things. Of course there will be. But for the most part, what sorry. For the most part, what we will be doing in that one class is one responsibility. So, just as someone has to build a car from its engineering drawings before you can actually drive it, you must build an object of a class before you can make an app perform the tasks the class describes. So what does that mean? You actually have to run the class. Normally, oh wow, that's lightning. That's really loud. I thought that was the dogs barking. So for the most part, in order for a class to do what it's supposed to do, you have to run it, or instantiate it and then run it. And you can actually do that through other classes. Normally there's a main class, or we call that a base class, and in that base class we run basically everything else from. You send messages to an object by making method calls. So remember in chapter 3 I created a method called static void Francis, and then I called that method. Well, that's exactly what's happening here. You send messages to an object by making method calls. So it would look something like this actually. And this is the actual program that we wrote in chapter 3. And I'm gonna create that method again, Francis. And I'm just gonna say console.writeLine name. Oh, actually no. I'm gonna not do that. What I'll say is what am I gonna say? I guess I can do this. I can say return okay, I got it. Name. I had to think about it for a second, what I wanted to do. I don't want to do console.readline. Yeah, I do actually want to do console.readline. So return name equal. Oh, and here's another thing you're about to find out. So notice I said name like I'm using JavaScript. In JavaScript, you don't have to define the data types. Well, in C# you do. So in this case, the name is going to be a string, so I have to call it string name. And then I can say name equals, and this is void. So this is another problem we're having. I said that the function was void when actually it's not. It's going to be a string. So what I should say is static string Francis, so that it'll return a string. And then I can say return name equals console.readline. And then in here, instead of doing what I did here, I can comment that out, and I can say instead of name, I can say Francis. Now, what do you anticipate is going to I need is static? What's the problem? There's no argument given. Right, I didn't give an argument. I should say console.readline, and then I should say return name. Now this is redundant, but I'm going to do it anyway. All right. So what is going to happen here? Well, and I'll actually comment that out or get rid of it. So when I ran this the first time, yeah, I'll save it. Why not? When I ran this the first time, what essentially happened is the program submitted to the console text, console.readline, or I'm sorry, the name of the person, and then this. What console.readline does is it queries the user in the console for text, and it won't it pauses the program and won't unpause the program until enter is pressed. So in this case, what I did was I said I wanted, and I created a function called Francis, or I could have called it username. It doesn't really matter. I'll call it username to make it more usable. So in this case, what I'm doing is I'm creating a function, a method, if you will. I gave it a overload. I said whenever you call the method, you need to make sure that you put a string in the method. Now you can have as many overloads as you want as long as they're separated by a comma. As a matter of fact, I can say, first name, last name, and then, or string last name, and then the person would have to, and then I would have to change that obviously to first name, last name, and then the person would have to actually put into two different read lines. I'm not going to make the user do that. That's just asinine for how easy this is going to be, or how simple we're making this. And then what I essentially did was I'm returning the name. So what does return do? What return actually does is return replaces, when this is run, it'll replace this entire call right here with whatever name is. The variable of name will replace this call, username with the console.readline. That's the point of return. Now, if this wasn't going to return anything, let's say this modified a list, or it printed something, but nothing returned from the function, I'd say void. And I wouldn't have it as a string. I would get rid of that because it's not returning anything, so there's no reason for it to have a data type. Now, obviously, that's not going to work in this case because I've already said that I wanted to return something, and I'm returning a string, so I want to make sure that I tell C# the function needs to be a string when it's said and done. So essentially what will happen is I'm passing it the string name, whatever that will be. It'll then return the name as a string here. And then I'm calling the function here, username, and I have to, this is called overloading with an argument. I'm overloading the function with an argument. Now let's run this and see what happens. It compiled just fine. And look, I got nothing. As a matter of fact, let's close that. I should probably tell the user to do something. So console.write, please enter your full name, right? And then we'll do that. Now let's run it and see what happens. Oh, there's build errors. Oh, I know why. Because I'm using single quotations instead of double, I believe. Let's see if that yep, that fixed it. And here you go. Please enter your full name. Now, remember, console.write doesn't truncate the lines, so I can say console.write, and it will write on the same line, and then the next line executes. So console.write executed. I didn't mean to do that. And it wrote this. Please enter your full name. Then the next line executed. Console.write line, username, console.readline. Once it sees readline, it pauses because it's waiting for an input from me, from the user. So I'm going to put an input. I'll put my name, Francis, and then I'm going to press enter. Watch what happens. Francis, welcome to the C# programming. Now, what happened? Whatever I added to the console.readline is now a string name. So we created the function, the method. Static means that I can call that method again. That's what it's called, calling. So static string is what this method's going to turn into when it's done. And then username is the name of the method. And then I overloaded it with a value or with a variable, string name. So in this case, I said username console.readline, so I'm asking the user to give me some text. And then what happens is this function or this method executes. So whatever's inside these curly braces is going to execute. In this case, we don't have much coming back. It's just a name. And then it returns it as a string here. So it replaces username console.readline and all these parentheses in the program with whatever I typed into the program because that's what I fed the function and told it to return. I know that sounds very convoluted, but that's how it works. Or I guess not convoluted. It sounds, back and forthy. But there's a reason why we do this. So let's pause it for a second. If we had a program that did a lot of different things, and we wrote all those things into this main function, how cluttered would that main function be? Moreover, how much would this function have to execute before it got to what you wanted it to get to? That can be a problem. That can make your program extremely inefficient. It can make it very slow. It can make it very hard to use. It can make users very upset because it is slow, inefficient, and hard to use. And I will tell you that in most situations, when the end user feels like they're having a hard time using your program, they're not going to use it. They're going to use something else. So always remember, it is much easier to write a program that the end user will use versus what they won't use. So always take a good hard look at user acceptance and user experience. The harder it is to use your program, the less inclined they will be to use it, even if they're told that they have to. So a car has many attributes, such as its color, number of doors, the amount of gas in its tank, and its current speed, and its total miles driven. These attributes are represented in its engineering drawings, but every car maintains its own attributes. Attributes are specified by the class's instance variables. Give me 1 second. Oh, there you go. Attributes are not necessarily accessible directly. Customers talk to a bank teller or check personalized online bank accounts to obtain their account balance. Similarly, you can use getAssessors to set assessors to manipulate attributes. So we can create a new project called Gradebook, and I'm going to go ahead and do that right now. So we'll go through the motions. So let's go ahead and close this. Close the whole daggone thing, please. Close solution. There we go. And new project. We're doing a console app. I'm going to name it Gradebook, because that's what they want us to name it. And we're going to press OK. And that should be fine. 4.6.1. Okay. And there it goes. It created it. Obviously, the first class is always called program. Don't sweat that. As a matter of fact, give me a second. One more thing. Do that. Do that. Do that. All right. Much better. I decided that music behind me talking is always nice. Classical really works out, so there we go. Remove that as well. Get that out of there. I can't? Alright, fine. Alright, let's keep it going. So, and here we go. I didn't write the void display message yet, but let's go ahead and write that in there to see what happens. So, I'm sorry. Let's actually make a new class. Because program.cs is not... yeah, let's make a new class. So, in order to make a new class in Visual Studio, what you have to do is you right-click on the... So, this is the project. This is the program. Kind of, yeah. So, the project can have many different programs in it. So, in this case, the Gradebook program's here. And what we're going to do is we're going to add... And we're going to say we want a new item. We want to add a class. Now, there's a lot of things in here, and it can get really, overwhelming. Don't really pay too much attention to the rest of this. I mean, it is good. Interfaces are used as well. Data sets are used. Code files are used. Entity Framework is big in when you start developing HTML, JavaScript, JSON, Storm Batch. I've never heard that before. TypeScript. I've been doing a lot of TypeScript lately. It's just JavaScript on steroids. It's a new version of JavaScript. WCF is an older version of REST. It allows you to do web-based data calls that sometimes are better than doing a SQL call. XML files also kind of old school. Let me see. Style sheets. So don't get too wrapped up in all of this. This is just, the things that you can make. For the most part, we're going to be doing classes because that's what we're doing in this class. So we're going to name the class Gradebook. All right, and here we go. Remember that whatever you name the class is normally what the class name is going to be in the namespace for the class is. So in this case, we're going to create our method. So public. Now, the reason why we name it public is because we want this method accessible outside of our class. So the Gradebook class may have multiple methods in it. But there are certain methods that we want to be accessible outside of this class. For instance, I want this class that I'm creating, display message, to be accessible outside of the program class or outside of the Gradebook class. More than likely, I'm going to call it in the program class. So in this case, I'm going to create it, void display message, and I'm just replacing whatever. I'm just rewriting what they wrote here. Remember, you write all your code within the curly brace. So, write line, please. Welcome to the Gradebook. And always remember your comments. So, displays message, displays welcome message to the Gradebook user. Boom. We're going to save that, and we're going to keep going. All right. And this is basically just a class declaration with one method. So, the keyword public is an access modifier. Now, what are access modifiers? They're exactly what I was talking about earlier. It is a way that we can make this method accessible outside of this class. Now, the OOP principle that we're using in this case is encapsulation. So there's 4 object-oriented principles that you need to understand. And this is before all the new age solid grasp and all that stuff. You'll more than likely get to that later on down the road. But pure object-oriented programming, what was developed in the 60s and 70s, revolves around 4 different precepts: abstraction, abstraction, inheritance, encapsulation, polymorphism. Abstraction is the ability to make modules or to fragment your code and make those fragments accessible to one another when needed. Now, abstraction can be more than that or less than that, but that's really what it is. And there's 18 million different definitions of abstraction based on whom you ask. That's my definition of abstraction. Inheritance is basically what it sounds like. If your father passes away, you inherit what he left behind. Same for your mother, if she so desires, I guess, or he so desires, she so desires. So, if you had a house and a car and $1 million in the bank, you would inherit that as his child, based on I forget the law. It's a specific law you have to execute. I can't believe I don't remember right now. I'm not thinking about it, so it's not a big deal. I'll remember after at the end of this course probably. But however, you also inherit the bad. So if he had $1 million in debt and the house was in foreclosure, or the house was being reverse mortgaged and whatnot, you inherit all that as well. So the same thing goes for programs. You can have a class inherit another class, and what will happen is whatever's in the class before it will then be accessible to the class that's being inherited, or the class that is inheriting it. You have encapsulation. Encapsulation is making sure that parts of your code are only accessible to other parts of your code. For instance, you don't necessarily tell your car... I'm sorry. Oh, I yelled in the mic pretty bad there. So you don't necessarily get in your car, or and in order to run the car, you don't open the hood and put your hand in the engine to make the car go forward, do you? No. You press the pedal. And if you want to turn the wheels, you don't get out of the car and turn them with your hands, do you? No. You use a wheel. The function of the wheels is encapsulated from you. The only thing that you have at your disposal is the wheel. The wheel disconnects you from whatever function needs to be done at the wheel level. The same is true about the engine. You don't get in the car and open the hood to turn on the engine, to run the engine, to make it go forward or anything like that. No, there are brakes and there's a ignition mechanism in the car's passenger location where people sit that you can control the car with. But you don't have full control of the car because you're not actually touching the engine. The same thing can be said for like this, for instance, this remote. This remote has a user interface, but there's also stuff within the remote that does the work. You are encapsulated from whatever is in the remote. You don't know how that operates. To you, it doesn't matter. All that matters is, can I manipulate it with the things on the outside? And that there's something very powerful about that. What that does is it does not only create a situation where your code is clean, not easily manipulated by other pieces of your code, or there's not these crazy tertiary dependencies all over the place. But what it also does is it makes for your code to be very secure. So that, for instance, in this case, it would be very difficult to manipulate it's really just a board in here. To manipulate the board to do something else other than what the remote is supposed to do, unless I break this open. I can't just take a soldering pin on the outside of this, or a soldering gun on the outside of this, and try to manipulate it. I would have to get to the board first. And the same is true for encapsulating your code. In this case, we're using encapsulation. There's also polymorphism, and we've been doing that in the entire time. What polymorphism is it makes your code modular. So I can use specific parts of the code when I need it, and when I don't need it, it doesn't execute. That's polymorphism. Yikes, that was loud. So, in this case, we're using encapsulation. And we're making this method accessible to other classes. But if I didn't want it to be accessible to other classes, if I just wanted it to be accessible to Gradebook, then I can just say private. And what private does is it's not only accessible to just that class, in most situations it's only accessible to itself. I can also say protected. And what protected does is it just makes it accessible to this class with caveats. So right now I want to make it public, and that's that. That's called an access modifier. There's three main ones: protected, private, and public. So access modifiers determine the accessibility of the properties and methods. The class's body is enclosed. Yeah, we know that already. So let's keep going. The method declaration begins with public to indicate that the method can be called from outside the class. We talked about that. The keyword void, known as the method's return type, indicates that this method will not be returning a value. We know that too. When the method specifies a return type other than void, the method returns a result to its calling method. We talked about that. What will happen is, whatever this method outputs, it's going to replace square2 with the value. That's what return does in your method. The body of a method contains statements that perform a method's tasks. So, and we've already done that. Okay, so we're going to create a gradebook test.cs. So let's do that right now. And let's add new item, class, and let's go ahead and create gradebook test. Add. There we go. All right. What next? We'll add the code. So this is the code that has a main in it. So why did I add a gradebook test if I already had a program? All right. So I'm not going to use gradebook test. I'm just going to use program because I already had something. So I'm going to delete this. This already has the main in it. I don't want to replace the main. So let's go ahead and go to program.cs. We already have a static. Let's add it. So gradebook. Now notice something. I'm typing in gradebook. But what is gradebook? Gradebook is a class. The minute I typed in gradebook, you see how IntelliSense knew what I was talking about? The reason why is because when I created gradebook, gradebook was then added to IntelliSense. And everything within gradebook was added to IntelliSense. So gradebook, the class, is added to IntelliSense. Gradebook, display message, which is in gradebook, was added as well. So when I go into program.cs, which is not a part of class, the gradebook class at all, and I want to use gradebook, I can. And this is called creating an instance of, or instantiating this class. Now, obviously, gradebook can now be used as a data type. The reason why is because I created a class that defines it. If I just, let's say this didn't exist, right? Let's say, for shiggles, and I'm going to erase this, I'm going to copy that. I'm going to delete this. So delete. Now, gradebook doesn't exist. It doesn't know what it is. It doesn't know where to pull this information from. I could right click here, do quick actions and refactorings, and then it would create one for me. See? Well, actually, no, it's refactoring it. I thought it was going to create the class. Oh, well, what's going on here? Gradebook. Here we go. Classes. Create. No suggestions. Normally, it would ask me to create a class. It's not doing that now. But I'm going to put that class back because I want it to know that gradebook actually exists. So we're just going to create it again. Add gradebook. And then I'm just going to go inside gradebook and put my method back. And now it knows that gradebook exists. Now it knows that gradebook exists without me having to add gradebook to the usings, because gradebook is a part of this project, this program. If gradebook was not a part of this program or somewhere else in the program, like another folder or whatever, more than likely I would have more than likely had to add it as a DLL. But in this case, I don't have to. So let's add the code. My gradebook. What I'm doing is I am creating an instance of gradebook. New gradebook. And this, let's see. All right, so we create the gradebook object and assign it to the gradebook variable. And then I want to call the method that's in gradebook. So then I can say, let's say call so I'm going to call the variable dot display message. Okay, let's run it. See what happens. Actually, what I should do is go here and tell it console.readline so that it does not just run and then go away. Save everything at 5 to run. And would you look at that? Welcome to the gradebook. So what just happened? In the main, when the console application ran, when I said execute this program, the main function of the application ran. This is called the main. In the main, I told it, I want you to create an instance of the class gradebook. I then want you to take that instance, so this is the instance of the class gradebook, new gradebook. You're creating the gradebook class here. I want you to place that object into a variable that is a gradebook data type variable. Alright, don't get too hung up on the details here. Just understand that the class created its own data type. You wouldn't be able to put the gradebook class into a string class variable. It wouldn't work. You have to put the gradebook class or whatever class you created into the same variable with the same data type as the class. So in this case, gradebook is the class that we created because that's the name of the class. And then what I said was, I want you to look into, so now my gradebook, this variable, my gradebook, is a direct representation. It is a working copy of the gradebook class. Think about that for a second. So let me use an example for a second. You have blueprints of a car, Toyota Camry. The Toyota Camry blueprints are then given to the machines at the factory. You said, I want you to make me a car. And it makes you a car. Boom. That's what we just did. Car number 1. We just made car number 1. Now, in car number 1, or gradebook in this case, has all the functions that are in the blueprint. So now all I have to say is, okay, now I want you to take that variable and I want you to execute the method that exists in that variable that is now a part of this, that was a part of the gradebook class, and it executed. And we got what was supposed to happen. I could do this many different times. I get many different instances of the class, and it would never be the same instance. I can do this multiple times. I can say that this is gradebook second GB for gradebook, new gradebook. Okay. If I executed this, I would get 2 variables with the same class in it. Now, would they be the same class? Of course not. They would be 2 different instances of the class that can do 2 different things simultaneously, separate from one another. Why? Let's go back to the example. We have a car factory, Toyota Camry car factory. Now I have 2 cars I want to create. Car number 1 and car number 2. Car number 1 gets pushed out. I ask car number 1 to give me the display message. Car number 2 gets pushed out. I don't ask it to do anything. Will they both give me a message? No. Only car number 1 will give me a message. Car number 2 will not give me a message because I didn't ask it to. That's how this works. When you create an instance of the class, what you're essentially doing is you're creating a workable object from that class. And you can create as many instances simultaneously as you want, regardless of how many classes you're calling, even if it's just one class. It's a lot to wrap your mind around, but and I didn't have that up at all, did I? Oh man. But here we go. My gradebook. I have 2 instances of my gradebook, or I have 2 instances of the gradebook, and blah blah blah. And if I went back to gradebook, you can see where the display message is. But just know that these are 2 separate instances of the same class. 2 separate instances. They're not the same. They do have the same class parameters and everything that's in that class within them when they were created, but they are different. And hopefully later on within this chapter, we can go over what makes them different. But let us continue. Any class that contains a main method can be used to execute the app. A static method is special because it can be called without creating an object of the class. In this case, gradebook test, in which the method is declared. So, remember, static is special because it can be called without creating an object of the class. It just means that you can call the method anywhere you want and not have any problems, normally within the same class. So 4.3 represents a UML class diagram for class gradebook. Classes are modeled as rectangles with 3 compartments. The top compartment contains the name of the class, the middle compartment contains the class's attributes, the bottom compartment contains the class's operations. The plus sign indicates that display message is a public operation, and hopefully it'll give that to us. And here we go. This is a UML diagram of what gradebook looks like. And in the gradebook you have the method. Obviously there's no variables, no global variables in that class, so there's nothing to display above it. A method can specify parameters, and I showed you how to do that with the other program that we wrote with the console.readline and all that jazz before we did gradebook. And I created parameters that I could I lose my train of thought, I'm sorry. We created parameters that then we can fill with arguments. And here we go. A method calls supply values called arguments for each of the method's parameters. So, and we talked about all this already, so we're going to just keep on going. And here we go. So now they want us to add a parameter, string course name, to the method. So let's go ahead and do that. And let's go ahead and fix our string. So what does that mean? That means new line. What does that mean? That means give me the 0th position. And the 0th position of what? The object argument. Here. You can see it. It gives us the little IntelliSense to show us. And you can do as many as you want. I'm not sure if it's unlimited or not, but you can do a lot actually. Press enter. And we're good. Or are we? Let's save that and see what happens. We just got an error. Why? Why do we have an error now? There is no argument given that corresponds to the required formal parameter course name. If you put an argument, a parameter in your method, so in this case we added an parameter to display name, you cannot compile the code correctly without errors until you fill that parameter with something, otherwise known as an argument, when you call it. In this case, we're calling it here. Here, this is called initializing. We're writing the blueprint. This is what I want it to do. And then when I get to the main function, or wherever I call that method, I'm calling it. Now I have to fill it with a value. A value needs to go here. So, let's flip back over. And here we go. So they want us to create a new gradebook. They want us to get text from the user. And then we're going to overload this method, display message, with an argument. Alright? So let's go ahead and do that. Let's go ahead and change that. Prompt for username. Console.writeline. Please enter the course name. And then I want to retrieve that, so, and I don't want that as right line. Actually, I want that as right because I want it to be on the same line. String, course name, or C name works. And then console.readline, because I want it to get whatever it's supposed to get. And then I want it to make a space, so console.writeline. And then whatever. Alright. And then I'm going to put the variable in here that I'm retrieving from the user. Alright, let's see what happens. So what happened? Please enter the course name. I spelled it wrong, but it did what it was supposed to do. So the course name is CIS 214, Object-Oriented Programming with C#. Welcome to the gradebook. Would you look at that? It added it just fine. Now, I don't like the fact that it did that, so I'm very particular about the way things are formatted. So instead of doing new line, let's just do it there. There we go. And let's run that again. So, and I also need this to be a lot bigger so you can read it. There we go. So please enter the course name. The course name is CS214. And there you go. Welcome to the gradebook, CIS 214, Object-Oriented Programming with C#. Boom. Boom. There you go. So what happened? Well, let's go read the main to find out what happened. We created an instance of the class gradebook. We then took that instance of the class, so new gradebook is the instance. We said, I want a new instance of the class gradebook. I want you to put that new instance of the class in the variable gradebook, that is the data type gradebook, or in the variable my gradebook, I should say. Then I want you to write some text and ask the user for the course name. I then want you to retrieve what they type after they press enter and put that into string CNAME. I also then want you to create a space. Then I want you to execute display name or display message from my gradebook. And I want you to pass the string CNAME as an argument, and whatever happens after that happens here. So in this case, what will happen is string CNAME will get passed to this variable string course name, and then it'll be written to the page. That's the way it works. Let's keep going. So, and there you go. That is actually what happened. I didn't like that, so I changed it. The method's parameters list is located in the parentheses that follow the method name. Any parentheses indicated that empty parentheses indicate that a method does not require any parameters, or that you forgot to add parameters. Empty parentheses indicate that a method does not require any parameters. That's correct. I'm sorry. The argument value in the call is assigned to the corresponding parameter in the method header. So, normally, objects are created with new. One exception is string literal, that's contained in quotes, such as hello. So, what this is saying is the only object that doesn't require the name new to be created are strings. Everything else needs the name new. What do I mean by that? So when we created the class, we said new gradebook. If I wanted to create an array, I would have to say string array equals new array. That's how you would create an array. I don't know if I have to say new string array, but yeah, either way, I would have to say new array. Do we get a number? Is that what makes it stop doing that? You cannot create an instance of an abstract class or interface array. New string array? String array? Did that work? I don't remember how to do it, but either way, it's new. So this new right here creates an instance of the array. It works for everything except for strings. String literals are string objects that are implicitly created by C# the first time they appear in the code, and you don't have to say new in front of it. Just these parentheses, quotation marks. I'm sorry. A compilation error occurs if the number of arguments in a method call does not match the number of required parameters in the method declaration. So, if a program or if a method requires you to have more than one parameter, so this is a parameter here, more than one parameter, and when you call the method, as we did here, and there's only one argument or no arguments, it'll throw a compile error. It won't execute correctly. Compilation errors occur if the type of arguments in the method call are not consistent with the data types of the corresponding parameters in the method declaration. So, what that is saying is, in this parameter, so I'm back in gradebook class, In the gradebook class, we have a parameter called string course name. But let's say this was not string course name. Let's say we said that this had to be an integer. Or let's say we tried to pass it an integer, like this. So instead of saying console.readline, let's say I wanted to pass it the number 15, which is an integer. And I said that's an integer or int. What will happen? Save that. I got an error. What does that say? Argument 1 cannot convert from int to string. What is it talking about? Well, what it's actually saying is the variable CNAME is a data type integer. But what the method is asking for is a string. You didn't give it a string. You gave it an integer. Please fix that, because it won't accept the integer and it'll throw an error. As a matter of fact, if I try to run this, I'll get a build error. And if I said yes, it would still not work. And look at that. It displayed the error at the bottom. So if I put this back the way it was, string, and then I change this back to how I had it, or give it a string. In this case, I'm just going to change it back to console readline. The errors go away, because the data type of what I'm passing as an argument to the method display message is the same data type, string. If they're not the same data type, when you're passing an argument to a parameter, it's going to error out. The UML class diagram models the class gradebook. The UML models display messages parameter by listing the parameter name and type. And here we go. That's the name of the method. This is the name of the class. And that is the parameter and the type of parameter, the data type of the parameter. Think of a parameter as a variable. Think of an argument as the value. Classes in the same project are considered to be in the same namespace. Using indicates that the app uses classes in another namespace. Without using, we would write the fully qualified class name, system.console.writeline. Notice I'm only writing console.writeline. The reason why is because I'm using system. So if I erase that, what would happen to console.writeline? It would go the way of the dodo bird. So if I didn't want to write using system and I just wanted to call that one method, or that one class, that one method from system, I would have to actually implicitly write it or explicitly write it there. And oh, would you look at that, it resolved. But because I have multiple consoles here, it just makes more sense to not have to do that and just go using system, and boom, all three of them are automatically resolved to the class system. Variables declared in the body of a method are known as local variables. When a method terminates, the values of its local variables are lost. Attributes are represented as variables in a class declaration. When each object of a class maintains its own copy of an attribute, the field is known as an instance variable. Class gradebook maintains the course name as an instance variable so that it can be used or modified. So let's talk about that for a second. So in this case, the method main contains the variable gradebook. However, if I just so happened to write a method out here, so read only string name, that won't work. Yeah, well, name. What'll happen? This is now accessible. This variable is now global to this class. It is accessible to that class and everything in the class. This read only string name can be used outside of the method main as well as inside the method main and in any other method that I write in this class. That can be very powerful and very awful all at the same time. If you can try to avoid it, avoid global variables at all costs. They're very inefficient and they make your code very insecure. The only time that I would actually recommend using variables that are global like that are when you're doing dependency injection. But that's way beyond how complicated this course actually is. It's a facet of .NET Core though, so eventually you're going to learn about it. I don't think that I'm going to teach it to you through the text or through the class, but if I get an opportunity to, I will try. And here we go. So here's a global variable name, course name, and we're going to use course name inside of a method. So let's write this. Let's go to gradebook. All right, and let's write this global variable, private string course name, and book. And then let's create the method that it uses. So property to get and set the course name. Public string course name. That's weird. They didn't do the curly brackets. Get. I didn't like that. Is that an interface? I wonder. Property or indexer must have at least one assessor. Yeah, I know. That's what I was trying to do. All right, cool. Oh man, I was losing my mind for a second there. But I did not lose it. Return course name. We're creating getters and setters. Set course name equals value. So there's a instance of a private string called course name. Now, what makes it private? What makes it private is I already have a property. So what makes this private? Why is it doing that actually? Can I do that? There we go. Much better. Much not better. Yeah. Okay. Let's not do that then. Let's do that. Much better. Okay. So I'm sorry. I was losing track for a second. Private is the assessor here for the variable course name. What this is saying is that the variable course name can only be accessible to anything within this class. Anything outside of this class won't be able to access this variable. String, on the other hand, is the data type of the course name variable. So private tells us who can access course name. String tells us what the course name data type is. And then we created a property that will get and set the course name. And we're going to go over what getters and setters are. But in this case, we have a public string named course name. When we get it, it's going to return the variable course name. When we set it, it's going to set the variable course name to a value. So when I get course name, it should return this, whatever's there. When I set this string, it should set this private variable. What this public string does is it makes course name accessible outside of this class without actually making the actual variable accessible outside of the class. It's a form of encapsulation. It's protecting the private string course name from other classes, hiding it in so much. So think of private string course name as your engine, and think of this public string course name as your pedal. What this does is it controls the engine, but it is not the engine. Without the pedal, the engine can still run and do whatever it wants to do, if it can, or without it, well, actually, without any inputs, it wouldn't be able to do anything, which is exactly what you want. All right, and we have, so here we go. Instead of having this course name, now this private string that's never going to display in this parameter location, what I'm going to do is I'm going to say course name. Now, what is course name? It's a public string that is only that is only powered by course name. So think of this public string course name not as something that holds a thing. It doesn't hold anything actually. All it does is it works as a means to get information to and from course name. Course name right here is the box. This course name is how you fill that box. You'll see in a second. So let's run this and see what happens. Looks like I did what I was supposed to do. I'm going to get my name. And actually, that's not going to work. And the reason why is because I'm goofing right now. Actually, I don't need that anymore. I don't need this anymore. Well, actually, before I do anything, let's see what the text tells us to do. I'm not going to change it. I might change it and it not be the same. Variables, properties, or methods declared with access modifier private are accessible only to members of the class in which they're declared. We've just said that 3 times. This is the 4th time now. Declaring instance variables with access modifier private is known as information hiding or Encapsulation. We talked about that. It is one of the 4 tenets of object-oriented programming. Precede every field and method declaration with an access modifier. Very important. Very important. Generally, instance variables should be declared private and methods and properties should be declared public. I'm going to say that again. Generally, instance variables, so in this case, we did course name, should be declared private. And methods and properties should be declared public. If the access modifier is omitted before a member of a class, the member will implicitly means naturally, or by default, or is implicitly declared private. If you get an error, hey, I can't access that variable, more likely than not, you didn't give it an access modifier. So what the program does is it takes the path of least privilege. Least privilege is a industry term for ensuring that someone only has the amount of privilege that they actually need. The default privilege for anything in your program, whether you put an access modifier there or not, is private. And that's following the principle of least privilege. We'll see that it's appropriate to declare certain methods private if they will be accessed only by other methods of the class. So some of you might be asking, why declare it private then? Isn't that redundant? No. You're doing it just to make sure that it is private. I mean, yes, by default, implicitly, naturally, it does it already. But we're doing it just to ensure when we see it as a programmer, we already know, oh, that's private. If I just see string course name, I might not think that is private. I might think that, oh, whatever. But private string course name will allow that to actually be implicitly or explicitly declared. So, declaring the instance variables of a class as private and the methods and properties of the class as public facilitates debugging, because problems with data manipulations are localized to the class's methods and properties, since the private instance variables are accessible only to these properties and methods. So, we need to provide controlled ways for programmers to get, retrieve, and set, modify, the value of an instance variable. Properties contain get and set assessors that handle the details of returning and modifying data. After defining a property, you can use it like a variable in your code. And here we go. The get assessor begins with the modifier get and is delimited by braces. The expression's value is returned to the client code that uses the property. Gradebook.CourseName implicitly executes the get assessor, which returns its value. The set assessor begins with the identifier set and is delimited by braces. So gradename.CourseName will set this value to course name, the private string course name, as we've denoted in our gradebook class. The text CS100 Introduction to Computers is assigned to the set assessor's keyword named value, and the set assessor executes. A set assessor does not return any data. Class gradebook test creates a gradebook object and demonstrates property course name. So, the get assessor gets the value, right? The set assessor sets the value. And it sets the value of whatever we want it to be set as. So, let's go click over to the code really quick. So, understand that this is not a variable. This is a property. There's a difference. The private string course name, that is a variable. Public string course name is not a variable. It's a property. And what it actually does is it gets, when you call it, I want to call this property course name, it looks at this private variable to get course name. If I want to set course name, it looks at this private string course name and sets the value. Only through this property can I set the value outside of the class if I want to set course name. Only through this property, because the variable itself is private. And this is the way that we allow the outside classes to manipulate or modify this variable. And this is what it looks like. So let's go ahead and rewrite our code. Just flip over really fast and let's do it. So write initial name of course, And in this case, what we're doing is we're looking at the myGradebook variable, and remember what I told you? So now you see that the gradebook class has a property, course name, and course name gets and sets the name of the course to the private variable course name. So I'm going to use that. I'm going to erase the comments. I want you guys to use comments, but I'm not going to. I'm just going to. I messed up, didn't I? Yes, I did. But I didn't realize I'm still going to need this. So we're going to say console.writeLine. Please enter the course name. All right. And then obviously I want them to enter it. Set course name. And then this is going to output a blank line. And then what I want it to execute is that. Now, there is no variable. I'm sorry. I want it to fill the variable course name. Remember? How do I do that? I need to use the property to fill that private string course name. So how do I do that? I'm going to call my class. Now remember, I instantiated the gradebook class in the myGradebook variable. So all I'm going to do is call myGradebook. That's what's accessible. That's what is relevant to this class. The instance of gradebook is now here in this variable myGradebook. So now I can call myGradebook, and everything that I need is going to be inside it. Gradebook dot course name. That's what I want. Now, myGradebook dot course name will contain whatever the user types in the console.readline. Stop. There we go. And this looks like it's good, actually. Yep. There's nothing here. Okay, so let's run it and see what happens. Ooh. What? Oh, there's nothing here in myGradebook.courseName. So when I run this, see how it says there's nothing there? So now I'm going to add something to it. And I also don't want it to be on separate lines. So let's do that. Start. So we'll do it again. There's nothing in that location or in the myGradebook.courseName. So now please enter the course name. The course name is CIS 214 OOP with C#. What's going to happen? Welcome to the gradebook. What happened here? Let's go back to gradebook. What happened was, and it's going to take a little bit, so bear with me. New gradebook created an instance of the class gradebook, and it assigned it to the myGradebook variable. So now myGradebook contained everything that's in gradebook. And now there's an instance of the class gradebook in this variable, which is, of course, data type gradebook, so it'll run correctly. Then I said, I want you to print this string, and I want you to add myGradebook.courseName to it. Now, what is myGradebook.courseName doing? This is a get. All right, if I actually scroll over, it doesn't say it, but this is getting what is in myGradebook.courseName. Now, on initial load, there's nothing in myGradebook.courseName. Because, what is it doing? Well, course name is a public string property. It's a get, a getter, and a setter. That's what properties do. They get objects and set objects. Get values and set values. So what is it getting? Well, it's returning. Remember what I said return means? Return means I'm returning a value. I'm returning something, right? It's got to be something of substance. A value, data, something. Something has to be returned from the variable, or I'm sorry, from the method, property, whatever. So what we're doing here is we are returning the variable course name. Why are we doing that? Well, because the variable course name here is private. If it's private, it's not accessible to this program, this class, is it? If I try to get that, yes. Let me get rid of that. If I tried to get, let's say I wanted to try to get that private string course name. Let's say I wanted to use it here in program, the way it is, without having to do the getter setter. I said myGradebook.courseName. What would happen? It would change it to the property. Why? Because to this class, that variable does not exist at all. It can't see it. It doesn't know it exists at all. It doesn't care if it exists or not. It is only accessible to this class. In order for the program class to manipulate or modify this variable, it can't do it by touching it. It has to use the pedal. Remember when I talked about the car? You don't reach into the engine to make it go forward. You press the pedal. So what this property really is, it's the pedal. We're pressing it to get, mosquitoes up here. We're pressing it to get the value, and we're letting it go, or I guess you can say pressing the brake to set the value, or vice versa, however you want to look at it. So in order to get course name, or in order to get the course name variable in the property, I'm saying whenever the property is called, I want you to return the variable course name. Now, obviously, to this property, course name exists because this property is a part of my gradebook. It is an extension of my gradebook, but it is not this variable. I will say that again. The property course name, this right here, the public string course name property, is an extension of the gradebook class, meaning that it can be pushed to other classes to get data or retrieve data, get data or set data, but it is not this variable. The variable itself is contained within the gradebook class, and no other program can access it because the accessor is private. If I wanted to set course name, I would have to use the property, and obviously it knows that I need to set, and it says set course name to the value that is placed on the right side of the assignment. So how are we doing this? Here. MyGradebook.CourseName equals whatever the user added to it. So you can really look at this as saying string course name equals whatever the user set the course name to. We're just using we're using this property to do it instead of doing it directly to the variable. All right, let's keep going. And of course, that's what we got. Give me 1 second. Ooh, I did not want to do that. Sorry. All right, halfway there. What? There we go. Boom. Next. All right, let's keep going. Unlike local variables, every instance variable has a default initial value. The default value of an instance variable of type string is null. When you display a string variable that contains the value null, no text is displayed. Now, what does null mean? Let's go a little deeper into what null actually is. Null doesn't mean zero. Zero is a value. Zero is a data, or is data. Null actually means there is nothing in that memory location. A variable always takes up one memory location in the RAM. Null means there's nothing in that memory location. No value at all. It doesn't mean zero. Actually, it doesn't even mean nothing. Nothing is still something. Because in order to get back the idea of nothing, something must exist to prove that there's nothing there. In this case, that's not the case. Nothing is nothing. Or null is absolute zero. Absolute nothing at all. Figure 4.9 contains an updated UML class diagram for the version of class gradebook. We model properties in the UML as attributes preceded by the word property and guillemets. To indicate that an attribute is private, a class diagram would list the private visibility symbol, a minus sign, before the attribute's name. And here we go. Property, and then the property's course information. Now notice that, I don't know if that's really loud. Let me see if it's exorbitantly loud and try to do something about it. There we go. Coolio. UML class diagram indicating that class gradebook has a public course name property. Notice that you don't see the private variable. Now it should be there, but it's not there right now. But it does show that the property course name of type string exists, and it shows that the displayed message method also exists. Properties allow the class to control how the data is set or returned. We talked about this. For example, get and set assessors can translate between the format used by the client and the format stored in the private instance variable. Properties of a class should also be used by the class's own methods. Notice that course name's get assessor simply returns course name's value, and the set assessor simply assigns a value to the instance variable. We talked about that. For such cases, C# provides automatically implemented properties as in get set. If you later decide to include other logic in the get set assessors, you can simply modify the properties implementation. A variable of value type, such as int, simply contains a value of that type. And here we go. Int count equals 7 is equivalent to that. A variable count of a value type int contains the value 7. 7 is an integer type. Count is the name of the variable. A reference type variable, sometimes called a reference, contains the address of a location in memory where the data referred to by that variable is stored. Whales. I can do the words. Such a variable is said to refer to an object in the program. Line 11 of figure 4.8 creates a gradebook object, places it in memory, and stores the object's reference in variable myGradebook of type gradebook as shown in figure 411. I think we're gonna get there pretty soon. Reference type instance variables are initialized by default to no. We talked about this. A client of an object must use a variable that refers to the object to invoke or call. You're gonna hear me say call a lot. Call. So, a client of an object must use a variable that refers to the object to call the object's methods and access the object's properties. And here we go. MyGradebook is the variable that contains the gradebook object, which can extend the course name property to the private string within the gradebook object. There we go. A variable's declared type, int, double, or gradebook, because gradebook is a type based on the class that we created, indicates whether the variable is of a value type or a reference type. If a variable's type is not one of the simple types, or an enum or a struct type, which we're not going to talk about here, then it's a reference type. For example, account being this, I'm going to assume that account's a data type. Account1 is a variable, indicates that account1 is a variable that can refer to an account object. An account object being either an account class or something as usable as that. Give me 1 second. Okay, cool. Each class can provide a constructor to initialize an object of a class when the object is created. The new operator calls the class's constructor to perform the initialization. A constructor. I wonder what that is. The compiler provides a public default constructor with no parameters, so every class has a constructor. So, if I go to our code, actually, that there. Cool. So, when the gradebook, or when this program is executed, gradebook has a constructor that is created for the gradebook class. However, we can actually create that constructor ourselves by doing the following. Now, what is a constructor? A constructor is what is executed first when the instance of gradebook is created. I will say that again. A constructor is what is executed first. It is what is constructed when the class gradebook is instantiated. So, for instance, here in new gradebook, the first thing that's executed in this right here is this constructor, public gradebook. Now, if this wasn't here, that doesn't mean that it doesn't have a constructor. It still does. I just haven't manipulated it or called it explicitly. It's there. I just haven't made it. Or I haven't referenced it. I can reference it and add things to the constructor. as I assume we're going to do very soon. So, when you declare a class, you can provide your own constructor to specify custom initialization. So, here's the instantiation of the gradebook class, and then I can overload the gradebook class with a value. This will get passed to the constructor. CS 101 Introduction to C# Programming is passed to the constructor. And the next thing will contain the custom constructor. Remember what I showed you? That's what I created before. So let's change this up a bit. And let's say, instead of having a private course name, we're just going to do the following. We're going to have a public string course name property with the get and set parameters already assigned to it. This will work to our benefit. We're not going to need to set and then close bracket. Thank you very much. And then we're going to create the constructor. So here's the constructor. Public gradebook. String name. I don't like that. And boom. Now, what's important about this? Well, I'm about to show you. What just happened there? What did I just do in the constructor? I set the property course name to the name that's overloaded in the constructor. How does that work? Well, I'll show you. Right now, the gradebook property, or I'm sorry, the gradebook class has a constructor. Okay? The constructor has a parameter. Now, remember when we talked about parameters earlier in the chapter? We said that if there's a parameter in a method, you have to fill it with an argument when you call the method, or what? You're going to get an error. Well, the constructor is a method. It looks like a method. It has curly braces like a method. It has a assessor like a method. It has an overload, a parameter like a method. It is a method. This is a method. It is a very special method called a constructor. What I have to now do is fill new gradebook. Whenever I call gradebook, I have to fill it with a string of anything. Now, I named it name because inside the constructor, I want to set the property course name to the name. So in this case, I'm going to call this let me see, CIS 214 Intro to C#. All the errors went away. Let's see what happens. What happened? Well, let's go over it. So, the main fired. An instance of gradebook was created and added to the variable myGradebook of data type gradebook. When the gradebook instance was created, the class gradebook instance was created, it required you to add a string to it. The string was necessary in so much that you would understand, or in so much that it would fill the property course name. We have a public string course name property that is a get and a set parameter. We then said, I want you to set the variable or the property course name to the overloaded parameter that's in the constructor gradebook. Now, this will always fire when the gradebook is instantiated. This is directly tied to whenever we instantiate gradebook. So, instantiate means to create an instance of. Whenever an instance of gradebook is created, the constructor fires every single time. Think of it as the main of the class. It is the main function in this class. Every time this class is executed or create an instance of, the constructor fires. The constructor needs a name or a string name as we defined it as. What it will do is it will take that name and it will add it to the property course name. Well, it looks like a property was added because in this line, the next line after this instantiation occurred, we want to print the course name with a string behind it. Guess what? We got our course name because that's what we overloaded gradebook with. It worked. Not going to finish the program, but I'm going to flip back over to keep on going. And of course, I'm going to keep all that the same. I think I fixed that. Yeah, it's still course name. All right, cool. We're good. A constructor must have the same name as its class. If it's not the same name as a class, or you named it something completely different, it won't work. It'll be a different method. The constructor is the same name as the class. That is the only way the class will know this is my method. Whenever I am called, this method must fire. Like a method, a constructor has a parameter list. And we'll go to the next one to kind of see that. So, notice there are 2 instances of gradebook. Remember, I told you can make as many instances as you want. There are 2 instances of gradebook. Okay? And we're going to manipulate it. I was waiting for this. I'm glad that it's in the text. So, we have gradebook 1. And I don't like numbers, but we're going to do it anyway because reasons. And we're going to say gradebook 2 equals new gradebook CIS 102 data structures in C#. And then we're going to have 2 consoles because there's 2 gradebooks. So my gradebook no longer exists, so I need to create the right gradebook. Gradebook 1. I should do that. Gradebook 2. Gradebook 1. And I'm going to comment this out. Okay. And then I'm going to execute nothing because I don't want to execute anything out of that. So let's go ahead. I'm sorry, let's flip back over. So let's go ahead and run this. What are we going to get? Nothing, because I didn't tell it to wait. Let's tell it to wait. Nice. Get some good music going in the background. Boss. Alright, let's do this. Alright, so we have 2 instances of the same class being executed twice. Remember the analogy that I used for the car. You have a Toyota Camry factory. The Toyota Camry factory creates an instance of a car. It creates an instance of 2 cars, but each instance is different. The first car is not the same instance as the second car. If I manipulate the first car, it will not affect the second car because the second car is a car unto itself. Alright? So, let's execute this and see what happens. We got nothing. Oh, no, we got something. Hold on. There it is. So, gradebook 1, the first instance of the gradebook course or class is CIS 101 Intro to C#. The second instance of the class is CIS 102 Data Structures in C#. I can manipulate both of these individually and get 2 different outputs because they're 2 separate instances of the same class running at the same time simultaneously. Unless default initialization of your class's instance variables is acceptable, provide a constructor to ensure that your class's instance variables are initialized with meaningful values when each new object of your class is created. And here's a UML diagram that shows the constructor with the guillemets. And there's your constructor. C# provides 3 simple types of storing real numbers: float, double, decimal. Real numbers just mean that it has decimal points, or it has a decimal point. Type floats and doubles are called floating point types. Decimal values or decimal variables store a limited range of real numbers precisely, whereas floating point variables store only approximations of real numbers, but across a much greater range of variables. To type a decimal literal, you must type the letter M, uppercase, or M lowercase at the end of a real number. A class named account maintains the balance of a bank account. Account test creates 2 account objects and initializes them to 50.00M, uppercase, and -7.53M, uppercase. These are decimal literals. Using floating point numbers in a manner that assumes they're represented precisely can lead to logic errors. Don't assume how many decimal points you have in your floating point number. So if you have a dollar value or currency value, it's important that you understand that that currency value needs to represent something a little more adequate than 15 different decimal characters. You might have to truncate that down to 2. So don't assume that your floating point numbers are formatted correctly, because you can get some pretty gnarly logic errors if you do that. And here's the account class. I don't know if I want to write it, but here's an idea of what it looks like. You have the public account. What is that? Well, if you read the comments, it tells you. It's the constructor. We have a private decimal balance variable here. And what the constructor does is it uses the initial balance parameter to fill balance. I'm assuming that balance is a property somewhere in the code. Here's a property, balance. The reason why balance is defined is because it wants to validate if the value is greater than or equal to 0. If it's not, the balance is left unchanged. The value of the balance put into the balance property must be greater than or equal to 0. This is one of the only instances in where you will define the get set. Normally, if you want to get set a property, you just say get set. And you don't have to define the variable, you just do what I did in the code here. So if you don't have anything that you need to do to validate the setting, then you'll just say course name, don't worry about the private variable, and just be done with it. However, if you're in the case of this situation where this is a property, by the way, public decimal balance, you see the get sets, it's a property. The only time you'll ever have to write this out is if, in this case, as you're looking here, you have to do some validation of some kind to say if the value is 0 or whatever is coming back from the balance. If it is 0, and value stays the same. What value means is whatever I'm loading into the property balance. So in this case, in the case of gradebook 1 dot course name equals 1 equal sign. Wowzers. Anything to the right of that equal sign is the value that is being assigned to, or the value that's being set to the property course name. That's the way that works. The same can be said for count balance. So if I wrote this, I'm not going to write out the way that this PowerPoint is, but if I said account dot balance, everything to the right of the balance property within the account class will be set to that balance. Understand though that if you write this out explicitly like this, you have to define a variable. You have to, or it won't work right. And here's the account test. Account test looks like it's the main class in the project. And I'm not going to write it out, but you can kind of see how this is working. Convert to decimal console.readline. It's taking console.readline. Understand that console.readline will always give you a string. Always. So if you want to convert it to a decimal or a float or a number or an integer or anything else other than string, you have to say that. Convert.toDecimal. Convert.toDate. Convert.toInteger. Convert.toFloat. You kind of get the point. The same thing's being done here with convert_to_decimal, but it's pretty much just looking at the balances and it's converting everything and then printing out the balance to the end user here. And there you go. This is all. And if you want to run that yourself, you can. I'm not going to. I think this slideshow is going to be long enough. A value output with the format item 0C. I'm not even going to look at it. It's for currency. Appears as a monetary amount. Boom. So where would you put this? Well, if you do console.writeLine and then you had the squiggly 0C, what it would do is it would turn whatever that is. Normally it would be a value of a decimal, hopefully, or an integer, or a double or a float, into a currency. So it'll have, 2 decimal places and then an array of numerical objects before it. The colon indicates that the next character represents a format specifier. C stands for US currency. D stands for whole string numbers. Formats a string as a whole number. Formats a string as thousands separated. Formats a string as scientific notation. Formats a string as a fixed number. You can go over these yourself, but these are kind of nice when you don't really want to denote the specifications of certain things. You just want to have a shorthand. It's possible to declare the get and set assessors with different access modifiers. One of the assessors must implicitly have the name access as the property, and the other must be declared with a more restrictive access modifier. And we've actually went over this, where you can create a get set assessor with different access modifiers other than public. The benefits of data integrity are not automatic simply because instance variables are made private. You must provide appropriate validity checking and report the errors. Set assessors that set the values of private data should verify that the intended new values are proper. If they're not, the set assessors should leave the instance variables unchanged and indicate an error. We demonstrate how to indicate errors in Chapter 10, and that's later on down the road. And here we go. This is your UML diagram of what your class account looks like. Class account is the name of the class. That is a class itself. It has a property called balance. It has a constructor with the parameter of initial balance as a decimal. And it has a method with the parameter of amount as a data type decimal. Ironically enough, the way that this is written is the same way it's written in TypeScript. In TypeScript, you don't write string... I'll flip over. In TypeScript, you don't write string something. Actually, in TypeScript, you would write something string. So, honestly, this UML is getting you familiar with other languages, but I'm not going to go too deep into that because that's client-side scripting, and this is not the class for that. So, and that's it. So, that wasn't that hard. Well, I hope it wasn't. If it was, just reach out, let me know, and I'll see what I can do to get back to you as quickly as I possibly can, hopefully within a very short period of time. But for the most part, this has been C#, understanding classes, methods, variables, properties, objects, blah, 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 blah. It's a lot. If you have to watch this more than once, please do. You're not going to get it the first time. And if you do, man, you are a very rare species, and I would say good on you. This is kind of a hard concept to grasp because what you're doing is you're breaking apart the way the program works, and you're trying to use it in a way that would make it not only more secure, but more efficient and readable and white space and all that other stuff. So, with that being said, good luck, have fun, and I'll see you next time. Ciao.